This is AQA GCSE Chemistry. It is from the 2018 1H trilogy paper, and this is question 6. So it's a higher question, and the whole question comes up to begin. You can pause as you go and have a go. This is 6.1, 6.2, 6.3, and finally 6.4, and that's a 12-mark question in total. So let's go back to 6.1 and take a look. Group 2 metal carbonates thermally decompose to produce a metal oxide and a gas. Give the formula of each product when calcium carbonate is heated. Well, the clues are all in there in the question. A metal oxide from calcium carbonate, well, that is going to be calcium oxide. And when we thermally decompose a carbonate and we make a gas, the gas that we always make is carbon dioxide. On to 6.2, the relative formula mass of a group 2 metal carbonate is 197. Relative atomic masses provided for carbon and oxygen. Calculate the relative atomic mass of the group 2 metal in the metal carbonate and name the group 2 metal. Now, to begin with, you've got to remember a key fact, and that is that carbonate ions have a charge of -2. And that means that in a group 2 metal carbonate, there will be one of the metal with one carbonate ion. So the formula is XCO3. If you don't remember that crucial fact, you're going to start losing marks. Now, we don't know what the value of X is. That's what we're calculating. So I'm going to call X's value X. But we do know that carbon is 12, and we know that oxygen is 16. There are 3 of them. So that's 3 times 16. And all of those together are going to equal 197 because that's the total molecular mass. Now, if I rearrange that to make X the subject, and I have my 197, but I take away the 12 and the 48, that will give me a value of 137. What I then need to do is look on the periodic table for the group 2 metal that has a relative atomic mass of 137, and that is barium. On to 6.3, and your job here is to calculate the gradient of the line in figure 8 and give the unit for it. So I'm going to use the maximum amount of the line possible, and I'm actually going to go right the way across and all the way up at 2. And then going to find out what the values are for the changes. So for my volume of gas, I'm going from 0 to 330. And for my mass of group 2 carbonate heated, I'm going from 0 to 2. So that's 2. To calculate a gradient, I need to do change in Y divided by change in X. That's 330 over 2, giving us a value of 165. And the units, if you simply substitute the units into that same expression, I've got cm cubed divided by grams. And that means that the units are cm cubed per gram. Going to finish off with 6.4. 24 decimeter cubed of gas is produced when 1 mole of a group 2 carbonate is heated. Determine the relative formula mass of the group 2 carbonate W. So it is a 4-marker. This is a big one. We're going to take a look at what happens not at 24 decimeters cubed. We don't have that. But what we do have is 240 centimeters cubed. So if I take that, because that's out by a factor of 100, my 240 cm cubed gives me a mass of 1.45 grams. Now, if I remember that 24 decimeters cubed is 24,000 centimeters cubed, I can then work out what mass would have been formed if there were 24,000 cm, or how many would have been heated, if 24,000 cm cubed of gas had been formed. And it's going to be 100 times the 1.45, which is 145 grams. Now, from there, we know that 24 decimeter cubed of gas is produced when 1 mole is heated. So 1 mole has a mass equal to the molecular mass in grams. So at 24 decimeters cubed, it tells us that the molecular mass is 145. And that takes us to the end of the question.